Okay. Okay, let us talk about how to write a ratio. So here we see a bonsai of a bald cypress tree. And basically a bonsai is simply a smaller version of a regular sized tree. Yes? They don't get the trees that small, the trees grow that size.
Like clip on the little, they clip on some of the roots.
So, a particular type of bald cypress tree called the senator can stand 118 feet tall. What we want to know is, what is the ratio of the height of the bonsai, this tree over here, to the height of the senator tree? Okay? Now, in order to write a ratio, we have to have, what we want to do is express the heights in the same unit. Okay, so what we need to do, we can do one of two things. We can either convert inches to feet or convert feet to inches. Naya, which do you think is a better strategy? Converting feet to inches or converting inches to feet? And which one would that be for you?
Converting years to feet.
Why?
No, converting feet to
Inches. Why is that easier? Why is converting feet to inches easier, do you think? They're not more common. Feet and common. Feet and inches are equally common. Micaiah?
Try to turn inches into feet so it'd be a fractions more.
Oh, feet.
I wouldn't exactly put it that way, that fractions are hard.
Me too.
But when you're going from inches to feet, you do have to convert, you have to make a small number bigger, in which case you're going to have a decimal or a fraction, which is more difficult to work with. So yes, that is correct. But you always have a choice. You can convert, if you have two units, you can convert either way. One of your ways is going to give you an easier way, easier numbers to deal with. The other one's going to give you more difficult numbers to deal with. Both are equally effective. So, according to Naya and confirmed by Micaiah, we're going to convert feet to inches. So, we need a ratio. We're going to put one unit on the top and one unit on the bottom. Now, the reality is it doesn't matter which unit you use, but you want to be consistent. So we're going to put the inches on the top and the feet at the bottom. So what we want to know is, what is the ratio of inches to foot? You know, feet. In other words, how many inches in a foot?
12.
12. So my ratio is 12 inches to 1 foot. Okay. It's not a vocabulary term, but this ratio that's going to help us change feet into inches, we call this the conversion factor. So the conversion factor says that for each foot I have 12 inches. So now, all we have to do is multiply. We're going to set up our ratio. We're going to get 118 feet over 1 times 12 inches over 1 foot. So all we have to do is multiply 118 feet times 12. And that's going to give us What does it say? It says 1,416 inches. You don't get it?
Oh,
Okay, now this is not the end of the problem. All we did here was figure out, all we did was convert one unit to the other unit so they compare. Okay, so that's only the first part of the problem, was converting so that my two units are the same. Now I can compare, now I can create my ratio. The way I write my ratio is going to be the height of the bonsai over the height of the senator. So what's the height of the bonsai? The height of the bonsai is 15 inches. The height of the senator was how many inches? 1,416. And now we can simplify this. We can try dividing this by 15. And if we get a whole number, then we're good to go. So let's see if we get a whole number. If we do 15 divided by, yikes.
I don't think that's a whole number.
Yeah. So what we need to do is we need to try to find common factors. Okay? Now there's only one set of common factors for 15, right? There's 3 and 5. So what we're going to do is we're going to rewrite our 15 as 3 times 5. Now, yes?
Could you just put 2016 on top of it?
No, because we're asked to find the ratio of the height of the bonsai to the height of the original tree. You're being specifically asked to put the bonsai on the top. And you have to go by what the wording of the problem says. If it said the height of the original tree to the height of the bonsai, then yeah, this would be, the senator would be the numerator. Okay, so now what we want to do is we're going to either divide this number by 3 or divide that number by 5. Now, hopefully, what should you recognize about this number?
It's the whole bunch.
Well, that's true. It is an even number. What is it not divisible by? It's not divisible by 5. How do we know that without actually doing the division?
The last number is.
That's right, the last number is a 6. So what we're going to do is we're going to break down 1416 into 3 times something. So we divide 1416 by 3, and that gives us 472. I can cancel out my 3's, and I get that the ratio is 5 to 472. Or, if I want to write it a different way, I can write it in that way as well, using a colon. Either way. Okay, does anybody have any questions? Okay, let's you try it. Okay, so please do this problem. First thing that Jonathan did is remember we have to have equal units. Both have to be feet or both have to be inches. And again, it's easier to go from a bigger unit to a smaller unit because you're multiplying. So Jonathan took 2 feet. He knew that the ratio of inches to feet is 12 inches is 1 foot. So that's how he got 24 inches. Continue, Jonathan.
Then I took 18 and put it over 24.
Okay, why did you put 18 over 24? Why didn't you put 24 over 18?
Because you want to get the bonsai tree and not the
With both bonsai trees. What is the question asking us to find the ratio of? The what to the what? The width to the height. So since we want the width to the height, what that means is the width is going to be the numerator and the height is going to be the denominator. Okay, continue, Jonathan.
And then I found one comment afterwards. Well, I got 3.
So you what? Divide it by each by 3?
Yeah.
Okay, so you divide this each by 3.
But now that I think about it, equal divided.
Okay, so you think, all right, so let's stick what you divided by 3, which gave you 6 out of 8, and then you realize you could divide, you now can simplify this by dividing this by 2, or, as Jonathan subsequently noticed, you could have just divided by 6 to start with. Notice this is not wrong. It wasn't wrong to divide by 3. The only thing you have to recognize is it requires you to divide everything by 2. So, the answer is 3 over 4 or 3 to 4. Okay. All right. Next thing I want to talk about is, as you can see, dividing a quantity into a given ratio. So here we have a problem. We have the school board buying tulips and daffodils. They plan to buy a total of 120. The ratio is 2 to 3. Okay? All right, so let's turn this into so what does this 2 to 3 represent? It represents the number of,
Is it 2 pots for every 3 pots?
come on, number of tulip pots, number of daffodil pots, and that's 2 to 3. Okay, there's a very easy way to do this. And that is to since what do we use when we don't know the quantity of something? X. So what are we going to do? We know that our total is 120. We know we're going to have some number of tulip pots and some number of daffodil pots, but we don't know how many. So all we have to do here is add an X. Add an X to both. Now, what are we going to do to get our 120? In English, what are we doing? Sandra, what are we doing? How are we going to get our total?
Divide.
What do you want to divide?
120.
So what is that going to give us? It's going to give us 60. Does that number help us at all? Maybe. Is anybody more confident? What do, in English, never mind the numbers that are up here. Tell me in English what we're going to do to get 120. Take your hood off, please. Divide. That's what Sandra just said. me ask you a question. Go to the grocery store. You buy 6 apples and 9 oranges. How many pieces of fruit did you buy? How'd you do that, Riley? But what did you do? You added. You added the number of apples to the number of oranges? Okay, well guess what? We're doing the same thing. Except we're not adding apples and oranges. What are we adding? Pots of tulips and pots of daffodils. So now, tell me what I need to do next to get my answer. Anna, you're not. So you know that already. Andy, what do I do next? In this problem, what do I do next? Now that I know that I'm adding, what am I adding together? Okay, be more specific. Tell me what to write on the board. Set up an equation for me. That's true, but that's not what I'm looking for. Can someone help Andy, please? Give me the equation. Now that we know that we're adding. Jack. Plus 3, plus what? Plus. Okay, does anybody not see where that comes from? If I want to know the total, what do I have to do? I have to add the components together, right? I got to add the different parts together to get my total. Well, what do I have here? I have tulip pots and daffodil pots. I take the number of tulip pots, I add it to the number of daffodil pots. That gives me my total number of pots. Now I'm going to do what? I'm going to solve for x. I combine like terms. 2x plus 3x is 5x. Then what? Divide both sides by 5. That tells me that x is equal to what? 120 divided by 5. Anybody? Stop guessing. Just take your calculator out and do it, please.
24.
Stop guessing.
24.
Okay, is 24 my answer? No. What is the question asking us? How many pots of each flower? So, how many tulip pots do I need to buy? So I need 48 tulip pots. And how many daffodil pots? 72. Okay, does anybody have any questions?